All right, so now we're going to talk a little bit about how to use the knowledge we just gained to predict the equilibrium in an acid-base reaction. Okay, so let's consider the acid-base reaction that we see here. There are two distinct ways to predict which side is favored at equilibrium. Number one is quantitatively. For this, you need to know the pKa values of HA, our initial acid, and HB, the conjugate acid that is formed once the base abstracts a proton from our acid, okay? The higher pKa value will be formed more, okay? So the equilibrium will lie at the higher pKa value because we know that that is the weaker acid, okay? Now, we need to know what the pKa values of our acid, in this case HA, and our conjugate acid are in order to actually be able to describe and make a determination on equilibrium based on pKa values. We don't always know that, okay? So what's our second way? Our second way is to do it qualitatively. We look at the relative stability of the base and the conjugate base that is formed. Okay, so that's B minus and A minus. The more stable conjugate base or base will be preferred. We are looking to find the more stable base. Okay, here's an example. Which side will be preferred? My reactant side or my product side? Well, I got nothing here in terms of pKa values, so I'm not going to be able to do this quantitatively. I'm going to have to try to address this question qualitatively by looking at my two bases and seeing which one is going to be more stable. Okay, so here I can see by looking at the overall reaction from my reactants to my product, it is the nitrogen on my reactant side that has gained a proton in my product side. So this must be acting as my base in my reaction, okay? Now, going backwards, the nitrogen loses its proton, and so it's this compound, specifically my oxygen with a negative charge, that is acting as the base on my product side. So which one of these two compounds is better at stabilizing the negative charge? Well, I'm going to go through my aerial list, and I see that my first letter is A, atom. Which atom is better at stabilizing the negative charge? Nitrogen and oxygen are in the same row. So I am looking for which one of them is more electronegative. Okay, the more electronegative atom, better at stabilizing that negative charge and will be preferred. Well, I know that oxygen is more electronegative than nitrogen. So it's going to be my product side of the equation that is preferred. Now, another important skill is to be able to choose an appropriate solvent for acid-base reactions. Okay, the solvent should be able to surround the reactants and facilitate their collisions without itself actually reacting or doing anything. Okay, because water can act as an acid or base, it has what we call a leveling effect on strong acids and strong bases. Okay, so acids that are stronger than H3O+, the protonated version of water, cannot be used in water. And bases that are stronger than OH, negative OH, or the hydroxide ion, cannot be used in water. And we'll talk about why a little bit in a while, okay? This is primarily important when dealing with strong bases. Okay, really strong bases, such as NH2. will react with water to produce the hydroxide ion, which is a much weaker base. Okay, this base, the hydroxide ion, cannot abstract a proton from a carbon, but our original base, the nitrogen with a negative charge, can. Okay. Now, we will be seeing this leveling effect we will not be seeing it for the rest of chapter 3, but we will see it again in chapter 9. When you get to Orgo 2, this becomes a bit more important when we're looking at slightly more advanced types of reactions.